Hello boys and girls, today we're on lesson 8.2, addition patterns, and we're on page 293 if you have your actual workbook. And our focus today, you should be able to say, I can find and explain addition patterns. I can also look for patterns to solve problems. All right, let's get into this. This green box here has a lot for us to do. And so I'll read through it first, and then we'll kind of do things step by step. So the first thing we're going to do, it says, is shade three sums that are next to each other on the addition table. And then add the first and third sums that we shade. And then find some kind of a pattern using that total where we add the first and third and compare that to the second sum and see how they are related. So that's this third part, see how they are related. And then finally, we have to check to see if it's true for other examples in that addition table. So here's our addition table. And we have boxes that are shaded in blue, right here, and right here. And those examples, I'm going to take those away, those are addends. And addends are just two numbers that we add together, or three or four or five numbers, whatever, however many there are that we're adding together. And then, sorry about that. And then, if we look, I'll get this figured out. There we go. If we look at those that are in the rest of the rectangle or square, everything in there are the sums. And sums are just two numbers, or three or four, that are added together. It's the answer. The sum is the answer to an addition problem. All right, so let's go through this kind of step by step here and see what we can find out with looking for patterns. The first thing it told us to do was shade three numbers that are next to each other on the table, and I'm going to choose these three right here, 40, 41, and 42. Second step, in yellow, add the first and third sums. So we're going to add 40, how about I grab a pen instead? We're going to add 40, that's the first sum, and the third sum, 42. All right, 40 plus 42. We add our ones column first, that's 0 plus 2. 0 plus 2 is 2. And then we add our tens column, 4 tens plus 4 tens is 8 tens. So 40 plus 42 is 82. All right, next we're going to look at the red. It says find a pattern using that total and the second sum. So we look at this total and compare it to that second sum. 82 compared to 41. Well, I can see that 41 plus 41, if I double that, I get 82. So 82 is twice as much as 41. Another way to say that is 41 is half of 82. So that's our kind of our relationship that those two have. That's how they're related. The first and third are double of the second sum. And then finally in black there it says, is this true for the other sets of three sums next to each other? So let's choose another. And I'll grab my highlighter and we'll highlight 30, 31, 32 here. Oh, and by the way, I guess I didn't talk about this earlier. To get 30, and a lot of you probably already know this, we use the addend 10 plus 20, and that's 30. To get 32, that would be, go all the way across here, that's 20 plus, what's up here, 12, and that's 32. Okay, so we're going to use the sums of 20, let me get rid of all this business, of 30, 31 and 32. So we add the first and the third, we add 30 plus 32. And some of you have probably done this in your head already using some mental math, but I'll write it out. Add my ones column first, that's supposed to be a 0 up here. 0 plus 2 is 2, 3 tens plus 3 tens, 6, 10, 62. Compare that with 31, and again, if we double 31, 31 plus 31, we get 62. So yes, that will have the same relationship no matter where we are. If we did the same thing down here with these sums, if we add 40 plus 42, we get 82. That's double of 41. All right, so that's what we're looking at, okay? And she tells us that we can look for relationships in the addition table. The numbers in the shaded column and shaded row are addends. We already talked about that. The shaded column and the shaded row, those are addends. Everything that has the white background, those were all sums. Adding those two addends together gets us the sum, or the answer to the addition problem. We're going to move over to the next page and look at some other examples here. And as we read what's in this top green box, it says Helen found the sum of the purple numbers in the red square, and then she found the sum of the green numbers, and then she's finding a pattern. And she's telling us that we're going to be able to use a variety of strategies to find some sums. So again, she took 44 plus 48, added those two together, and then she also added the two green numbers together, 46 plus 46. All right, she did that in a few different ways. First way she used is the associative property. And in our previous video, if you recall, the associative property tells us that we can group numbers differently and still get the same answer. So if we look at 44 plus 48 and see what she did, she took 44, all right, this one right here, used it normally, and then with 48, she actually split that up and made that 2 plus 46. So now we can apply the associative property and take the 2, and instead of grouping it with the 46, we group it with the 44 instead, and we have 44 plus 2, and that equals 46. And then we take our other 46 and keep it there. So it's one way for her to show that 44 plus 48 is the same thing as 46 plus 46. One thing I want to talk about before we move on, this equal sign, oh, sorry about that. This equal sign, it tells us something important. It doesn't necessarily mean that 44 plus 48 equals 46. That's what a lot of times some third graders might think. All that equal sign is telling us is that whatever's on one side, 44 plus 48, it will equal whatever is on the other side, and it has to be all the other stuff on the other side. Okay? So another way we could do this that she really didn't show is we can add 44 plus 48. And 4 plus 8 is 12. Well, 12 has two ones, and then it has a 10, and I'll put my 10 up here. Now I can add my tens column. 4 tens plus 4 tens is 8 tens, plus that other 10 is now 9 tens, and that all equals 92. And if I do the same thing with 46, add those two together, hopefully I get 92, if I do it correctly. Okay, 46 plus 46. 6 plus 6 is also 12. 12 has two ones, and then I take that 10, and it goes right up here. Now I can add up my tens column. 4 tens plus 4 tens is 8 tens, plus one more is 9 tens. So 44 plus 48 is actually, in one number represented, it's 92. 46 plus 46 also equal to 92, so those two sides are equal. Another strategy, we can use mental math. Instead of writing everything out like that, you can think about it in your head. So again, she starts with 44 plus 48. However, this time, she decided to add 2 to 44. Well, if she adds 2 to 44, she has to take 2 away from the other side, from 48. 44 plus 2 is 46. 48 minus 2 is 46. And again, we get this equation, 44 plus 48, she's showing that equals 46 plus 46. And then finally, we can use the commutative property and the associative property. And again, if you recall from the previous video, commutative property means we can just switch numbers around in an addition problem and we get the same answer. And again, the associative property means we can group them. So, what did she do? She started with 44 and then she split that up into 10 plus 34. And then she took 48 and she split that up and made it 12 plus 36. That equals 48. Okay. Now, she also did something similar with 46 and 46. 46 becomes 12 plus 34. And the other 46 becomes 10 plus 36. They both equal 46. Now she's going to use those properties to rearrange the addends. All right, so 10 plus 34 was this one right here. And 12 plus 36, again, was this one right here. And 10 plus 34 is, whoop, I missed my spot. 10 plus 34 is the 44, so that how she got that is 10 plus 34. So she used the commutative property and switched them around and then grouped them using the associative property. And then her 12 plus 36, I'm going to have to use another color, get messy. 12 plus 36 is this 12 plus this 36, and she regrouped those. Okay. Now the sum of the purple numbers is 92 still, because 10 plus 34 is 44. 12 plus 36 is 48. Okay. And the sum of the green numbers is also 92. 10 plus 34, 44. And 12 plus 36 is 48. So she just moved some numbers around to show that both actually are still 44 plus 48 and both equal 92. Pretty complex and maybe a little complicated, but it's just a way to move some numbers around following some math rules, and we get the same answer. If we look down at the bottom here, the sums are double the middle number in the red square. That is another pattern. So again, if we look, the number in the middle is 96, or 46, excuse me. But 46, if we double that, we get 92. And what do all those equal? 92. So if we have a 3 by 3 square, meaning we go across 1, 2, 3, and we go down 1, 2, 3, so we have a 3 by 3 square like that, and we have our sums in there. The diagonals, this one plus this one, is going to equal what's in the middle. And same thing on the other corners. This one plus this one will equal what's in the middle. Right? And we'll look at that here in just a moment as we turn the page. And it says, the very first question, are the sums of any two sets of diagonal corners in a 3 by 3 square in an addition table always equal? Okay, well, let's just pull up this one. And I'm going to draw in a 3 by 3 square. Okay, so we look at the diagonal corners, and I'll circle one, that's 40, and the other in the diagonal to that is 44. If we add those two together, I'm going to do that up here, 40 plus 44 is 84. Okay, all right, so let's then look at the other diagonal corners. That's 42 and 42. And we add 42 and 42, we get 84. Okay, so yes, they are always equal. Okay, why is that? Well, let's look in the middle here at 42. Let me use a different color. We look in the middle, right? So, well, actually, let's not look in the middle so much. To get this number right here. What numbers did we add? We added 20 plus 22, right? When we look at this number, what numbers do we add? 20 and 20 and 22, right? When we got 40, we use those same addends. And when we get 44, we use the same addends. We use the same addends for all those problems. And because we did, we get the same final sum. All right? You don't have to write that down, but it is something we'll just have to know. Hey, we use the same addends for all of these sums. Okay? Now, not the same addends every single time, but in the end, we used all the same addends. Okay. Do you know how? Look at the addition table in box A on the previous page. Why do the numbers going down to the right on the diagonal increase by 2? And we don't have to look at the previous page. We can look at this page right here. So I'm going to just kind of highlight some addends, and we're going to go down the diagonal to the right. That means going this way. And we'll look at those. And you'll notice as I'm going down and to the right, those numbers are growing by 2. But we have to know why, okay? Why do they go down by 2? Let me erase my other work here real quick because it got kind of messy. Okay, so why are we increasing by 2? And I'm actually going to start way up here at 42 and then do 44. Then we have 46 and 48 and 50 and 52. Well, let's look at our addends. To get 42, that was 20 plus 22. To get 44, what are my addends? 21 plus 23. What happened? Each addend went up by 1. It increased by 1. So if I increase this addend by 1, that's 1 more. And I increase this addend by 1 up here, that's another 1, so that's 2. I've gone up by 2, right? If we do that again, if we look at 46, I went from 23, my addend became 24, so I increased by 1. But this addend went from 21 to 22, I've increased by 1 again, so now I've gone up by 2, a total of 2. So that's why if we look at that diagonal, they increase by 2 every time because each addend goes up by 1. And we have 2 addends, each one goes up by 1. That means we've gone up by a total of 2. Okay, so how do we explain that then? We can just say each addend, how about if I use a pen instead of a highlighter? Each addend increased by 1. There we go. That's why. Okay, so if we look again, I'll just draw or write it out real quick. If I have 2 plus 4, that equals 6. If I increase each addend by 1, 2 becomes 3 and 4 becomes 5. When I increase each one and then add them, we get 8. So each addend went up by 1. My sum went up by 2. All right, boys and girls, so I'm going to leave the rest of the independent practice on this page and the next page up to you. Do your best, work hard, persevere. As always, it's Mr. P, and I'm out.